Hey guys, this is Alan with Bothell STEM Coach, and today we're continuing on with the AP Calculus 2015 free response questions. So now we're on number 3, which is the non-calculator portion. Okay, so Joanna jogs along a straight path for 0 is less than or equal to t is less than or equal to 40. Joanna's velocity is given by the differentiable function v. Selected values of v, where t is measured in minutes and v of t is measured in meters per minute, are given in the table. Use the data in the table to estimate the value of the derivative of 16. 16 is halfway between 12 and 20, so I'd use the secant line of 16 is approximately equal to v of 20 minus v of 12 over 20 minus 12. And so that's 240 minus 200 divided by 8. That's 40 over 8, and that's 5. Now the units of this is meters per minute, and that's minutes. That would be meters per minute squared. Okay. Using correct units, explain the meaning of the definite integral 0 to 40 absolute value v of t dt in the context of the problem. The context of this problem, absolute value of velocity is speed, and so over the 40 minutes, the integral of the speed is the distance traveled. This means Joanna jogged a total distance we'll say this total distance over 40 minutes. So it's the total distance that she jogged over the 40 minutes. Maybe that's how I would rewrite it instead. Approximate the value of this using a right Riemann sum with the 4 subintervals indicated in the table. Okay, so we need first we have to use the absolute value, which means this one has to get changed to 220 when we do this. Just FYI, since we're not integrating v of t, we're integrating the absolute value of v of t. I need to do the absolute value of these values. Now this estimate is let's see, we're going to use the right Riemann subintervals, and there's 4 subintervals: 0 to 12, 12 to 20, 20, so there's 1, 2, 3, 4 subintervals, and you use this value, so it's going to be 200 times the width of this interval, which is 12 minus 0, plus 240 times this interval, 20 minus 12, plus 220. Again, it's positive 220 because we're doing the absolute value of 24 minus 20, plus 150 times 40 minus 24. And so, we don't get a calculator for this. Okay. Approximately, so this is 4,800. This is 8 times 24. What's 24 times 8? I don't know why I can't do this. 192. 192. Let's see. 8. 920. There's 1 0 because 8 times 240. Plus 4, that's 880. And this is 16 times 150, and that's 9,000? No. 16 times 15 is 160 plus 80, that's 240. Sorry, 2,400. So this is 4800. Okay. Sorry, I'm just making sure I did the math right here. Okay, so this plus this is 2,800. This plus this is 7,600. 7,600 plus that is 10,000. 10,000, and the total distance is meters per minute times minute. That's meters. Nice even number. C, Bob is riding his bicycle along the same path. Bob's velocity is modeled by this, where t is measured in minutes and b of t is measured in minutes per minute. Find Bob's acceleration Okay, so Bob's acceleration is the second. Let's see, this is velocity. Acceleration is the derivative of velocity, so they just want the derivative of this, and they want it at time t equals 5. So this is 3t squared minus 12t. The derivative of 300 is 0. And then at 5, I plug in 3 times 5 squared minus 12 times 5. That's 75 minus 60, or that's 15, and then it would be meters per minute squared. 75 minus 60, yep. Okay, and then part D is the last one. Based on the model B from part C, find Bob's average velocity during the interval. Well, okay, so the average velocity is always the integral of v of t. It's any average. You integrate it, and then you divide it by the interval, right? B minus a. So in this case, we're going to integrate the velocity from 0 to 10 of t cubed minus 6t squared plus 300 dt over 10 minus 0. 1/4 t to the 4th minus 2t cubed plus 300t, evaluated from 0 to 10, all over 10. So that's equal to, let me draw lines, so just separate out. That's 1/4 10 to the 4th minus 2 times 10 cubed plus 3,000 divided by 10. So this cancels. This is 1/4 10 cubed minus 2 times 10 squared plus 300. So this is 1,000 divided by 4. That's 250 minus 200 plus 300. And so that's 50 plus 300, or 350. And the units of this are meters per minute. Okay, so that's part D. So let's take a look at the scoring guide. Let's see. 5 meters per minute squared is the total distance she jogs over the time interval. Oh. 12 times 200. 12 times 200. 240 times 8. 4 times 220. 880. And then 16 times 50, which would be 24. So 2,400 plus 880. Man, if I missed it because I don't know how to add, that's really terrible. Why did I say that was 4,800? Right, is this one? This 2,400. Okay, well, I lost a point because I can't do arithmetic. I don't know why. Bob's acceleration, 15 meters per minute squared. That's correct. Average velocity, 350 meters per minute. Okay, so other than really poor arithmetic right here, I'm going to have to mark that in red for myself. This is wrong. 2,400. I thought I did pretty good. Again, not perfect, but you know, that happens sometimes. So thanks for watching, and I'll see you guys in question 4 of this free response section. Thanks. Thanks for watching the video, guys. I just want to let you know that I offer free homework help on Twitch or Discord. So just stop on by if you have any homework questions, or you just want to learn about different parts of math and physics and hang out. Hope to see you there.